Welcome to our overview of Cisco iOS DMVPN solutions. As with anything, before we start diving deep into the details, it's important to start with an overview and motivating reasons for using the service. So in this case, with the Cisco iOS DMVPN, we're going to get right on into an overview and understand that it offers better scale, especially for hub-to-spoke and spoke-to-spoke designs, optimized performance. And what they mean by that is optimize direct communication from spoke to spoke, or in this case, depicted as branch to branch. And then by the spokes, the branches being able to communicate with each other more directly, if not directly, that reduces overall latency in communication and then therefore the application. Now understand, please, with all these wonderful benefits, simpler configuration, automatic IPsec initiation to protect our traffic, of course, and then also support for dynamic branches or dynamic spoke-to-spoke communication, that means that there are going to be several components involved. And that's exactly what we're going to be discussing over here is our components. So let's go ahead and get on into it. First one, again, being multi-point GRE or MGRE. Understand we're using a protocol that's been around for a long time, generic router encapsulation, that enables the multiple part or the multi-point part. It enables a single tunnel interface to support multiple actual tunnels. So that right there, especially coming from the old days of having to configure GRE more manually, by having a single interface for multiple tunnels, that absolutely simplifies the configuration. And then please understand, IPsec is really good at offering security. IPsec is not good at supporting multiple different protocols. As a matter of fact, IPsec, if you remember from previous conversations, only supports IP unicast communications. So that's another example of where GRE comes into play because it supports multicast and non-IP protocols. Now let me pause just for one moment, folks. Modern day non-IP protocols would normally be, let's say, IPv6 or layer 2 protocols. The reason why I mention that is if we were to go back 20 years ago, non-IP protocols where GRE really shined many years ago was non-IP protocols would be IPX, AppleTalk, Vines, DECnet. We just don't see those protocols anymore these days, and we're not upset by it. So again, we just need to redefine what non-IP protocols are going to be. Now, if we continue on with NHRP or the next hop resolution protocol, for me, resolution is the key word. And in our industry, a lot of things are going to be very client server oriented. So if we go over here to the bottom right-hand side and talk about the NHRP client, these are, of course, going to be your branch or your spoke routers, and they do several things. For example, upon initialization, they will register their IPs, both their private subnets, their tunnel interface, and their public or reachable interface addresses with the NHRP server. And then additionally, later on, and we're going to talk about this coming up in a moment, the NHRP client will query the NHRP server, or said another way, the spoke will query the hub for other spoke IPs, reachability to other spokes. And then last but not least, if we go over here to the NHRP server, once again in our client-server relationship, when the NHRP server receives that registration from the NHRP client, it maintains a database, or I like the term mapping table, of again the outside public reachable IP with the inside tunnel interface. And this nice dynamic registration and then maintaining a database simplifies the overall configuration of how do we reach the other locations. Also, if we have ourselves dynamic spokes coming up, going down, dynamic spoke-to-spoke communication, we could support multiple different routing protocols. And when I say multiple, I mean RIP, EIGRP, ODR, OSPF, and BGP. And if you're thinking to yourself, whoa, wait a minute, I've heard about all of those routing protocols except for ODR. Is ODR new? First off, ODR stands for on-demand routing. It is not new. It's something that has been around for many, many years, and it actually uses Cisco's Discovery Protocol, or simply CDP, as its transport mechanism. So if you find yourself with plenty of free time, go in and look up a little bit more. If ODR, on-demand routing, is new to you, go in and look up more information on it. And then let's not forget, folks, last but not least, the multicast support, the non-IP protocol support. That's all, once again, going to happen inside of GRE. And then GRE rides inside of our IPsec tunnel. Because, again, it's very important for you to understand, GRE is wonderful at encapsulating. However, it's not good at all at providing protection, providing security, while the opposite is true with IPsec. IPsec is great for providing security and protection, but it is not good at all for providing encapsulation of multiple different protocol types. So they work together. It's a perfect yin and yang working together, like an ebony and ivory or keys on a piano working together to provide the overall solution. Now, as we finish up here on just DMVPN overview with, again, the different deployment models, a couple things to understand. We can do, as you see here on the left, just a hub and spoke, also known as a strict hub and spoke, but understand that your spokes need the connectivity, the definition to the hub router, and then all communication is going to be flowing through that hub router, that HQ router. So please understand, folks, in a strict hub and spoke, yes, all locations may communicate with all other locations, but the connectivity goes through the hub. And that's what we said earlier by there could be some latency issues instead of just, as we show you here on the right-hand side, spoke-to-spoke communication with the branch communicating directly to the other spoke or to the other branch. That is where, if you ask me, where all of these components come together. Once again, our multi-point GRE, the next hop resolution protocol, maybe our static or even dynamic routing configuration to allow, once again, branch to branch or spoke to spoke communication, or truly, to me, the real benefit of dynamic multi-point VPN. And then last but not least, at least for this graphic here, is you need to understand that there really are going to be two address spaces here. If you will, the private address space, privately routable, not public IP within your organization only, that is going to be on the tunnel interfaces, what's used by multi-point GRE. And then we have our public addresses, possibly publicly routable, external to your organization, and that provides initial reachability, especially for the IPsec tunnel.